This video showcases that there's basically no limit to what you can build in Langflow. And I will show you how I approach these large flows and some of the tricks I use. I won't go into detail on every component because we will be sitting here until tonight. Now, if you want me to go into more detail on some of the components, just let me know in the comments below. Now to the video. Okay, so this is a RAG flow, which includes an evaluation pipeline. And everything is inside Langflow. So usually RAG contains two components or two parts. One is the retrieval part, where you retrieve the documents or the chunks from your vector database. And the other part is where you use those chunks and your prompt to generate responses. And we want to evaluate both of them. So we want to evaluate the retrieval part and we want to evaluate the responses of the LLM. And again, everything is built in Langflow directly. So let's have a look at how this works. All right, so the first flow is where we ingest our data into the vector database. So in my case, I'm using Viviate, and yeah, I'm probably butchering the pronunciation, but that's an open source database which you can self-host or you can also use a cloud version. The special thing about this flow is that I'm using a special file loader which loads metadata such as file name and file path, which is required for retrieval benchmarking. And I will go into this later in the next flows. In general, it's also always helpful to have the file name and file path if you want your RAG flow to include citations. The second special thing is that I'm using a document ID based on the file path. So each document gets assigned to a document ID. And this is important such that I can, when I update the document, I can delete the previous version. Otherwise, you will get duplicates of the same document, which you obviously don't want. So you need to have some labeling of these documents. And you can see here, I have this vector clearer, which I use to remove this document from my database before I then ingest the updated version or the updated chunks. Now, each of these chunks will have the same document ID, so it will grab all the chunks related to this one document and delete them. Now, this is the retrieval flow that contains a list of file names, a query, and a vector database index as input. I use the query to retrieve my vectors from my vector database, which contain the file path and the file name. I can then use those file names and compare them to my input file names to see whether the correct files were retrieved. I use a custom component to calculate all the relevant metrics. Usually you would calculate things like recall, precision, F1 score, false positives, MRR, MAP, and these are usually the normal metrics. So this is now how my output would look like. And you see there's one row which contains all the different metrics. This is then converted into a JSON, and this is then the output of my flow. Now the next flow iterates over the previous flow. So again, the previous flow was the retrieval flow, which we use to ask a query and retrieve our vectors from this flow. But this was just a single query. So now we actually have a list of questions, so a list of queries. And for each one of them, we want to do the prior flow. So for each one of them, we want to retrieve the vectors and basically retrieve the context or the chunks and create an output JSON. So here we can see I'm using a CSV file, which contains all the questions and it contains the information about the file name, which contains the answer to the question. Then I loop over my previous flow, as mentioned, using this subflow component to evaluate each query. And by the way, this process list component is a custom looping function, since this is an older version of Langflow. But the new Langflow version already contains a looping functionality, so you can already use the existing looping functionality and you don't need a custom component. The output of our subflow now are the metrics of each evaluation. So as I said, the output in our case is a JSON file, which contains the chunks as well as our metrics. Now, the last thing we can do is we can actually aggregate the metrics to get a mean and a sum based on the evaluated questions. So each question got evaluated, and we're now aggregating the metrics of each question to get an overall benchmark of our retrieval flow. This tells us now whether the correct files were retrieved. No LLM is needed here, but this part is actually super crucial for any RAG pipeline. All right, next up, we need to generate LLM responses in order to later evaluate them. And you can see this pipeline is actually currently running at the moment because I wanted to run out of them again. And this also takes the longest time to run. So this pipeline takes in a CSV file, which we can have a look at here. And this file contains the non-aggregated metrics for each query, which we have generated previously. And the file includes the query itself here, and it also includes the text chunks, so the context, which is in the text column. Another input is the system prompt, or I should rather say system prompt template, which we have defined here. And you have a context part and a query part. And because now you can already see what I'm doing, I will iterate over the CSV file and insert each query and context into the system prompt template, and then pass the final prompt forward to an LLM. So we can see this here. In my case, I'm currently using Olama locally, and I'm iterating now over each of these rows and generating a response for each of these prompts. Then the output will look as follows. So this is now from a previous run, because currently the run is still going. So this is just one test run with one example, but you will see here the response, the query, the context, and the system prompt template. And we are writing all of this again to a CSV file so that we can use it in the upcoming flows. Before diving into the actual evaluation, I want to showcase this intermediary flow. Right now, we've only evaluated one system prompt, but what if we want to iterate over multiple system prompts? So this flow allows it, and it's quite simple. We just load in a CSV file containing different system prompts, so different system prompt templates, and then we iterate over our previous subflow to generate multiple output CSV files which contain the query, the context, and the LLM responses for evaluation. This part is basically optional and only required if we have multiple system prompts and we want to automate this testing of different system prompts. So next is the LLM evaluation metrics flow. It's quite a long name. But this basically now evaluates the different responses we have generated in the previous flow. For this, we take in a CSV file. And if we look at the CSV file, it contains the query, it contains the context, and it contains the response. It also contains the system prompt template, but this is just for information. We only need the query, the context, and the response to be able to evaluate the response of the LLM. Now for the evaluation, I've created a custom component, and this custom component evaluates based on common metrics such as exact match, F1 score, rogue, BERT score, blue, meteor, semantic similarity. And these are basically the main ones you want to have in your evaluation pipeline. So this is how the output would look like. So we have each question and all the metrics for each of the questions. So the next step is to aggregate them. Once aggregated, this is what we will end up with. And this is the final evaluation of our responses. This is one system prompt and all the questions, I think it's something like 20 questions evaluated in this pipeline. And of course, both the aggregated version and the non-aggregated version are written into a CSV file so we can look at them. Now we have basically a table or CSV file for the retrieval part, as well as the LLM response part. Now let's talk about managing these different flows. I like to create this sort of executor. I'm not sure whether this is the best name, but we will just roll with it. Since I've structured each part into a separate flow, I can use Langflow's subflow functionality to run them one by one or execute them all in one go. I find this method 100 times better than creating one massive, unwidely flow, because big flows, they're confusing, and also it kind of gets laggy if you have so many components. So creating these separate smaller flows is actually not a disadvantage, because as I said, you can always just chain these different subflows together. So here we have the ingestion flow, which you can trigger manually. And then for the other flows, for example, the other flow would be to retrieve the results based on the questions. Then we will write our metrics to file. And these are the path to the metrics will be the output of the flow. So we take the output, and this is the input for the next flow, because in the next flow, we want to get the LLM responses. Then once we have generated these responses, they are written to a CSV file, and the path to the CSV file is again the input for the next flow, which is doing the actual evaluation and aggregation. And basically, if I would press this button here, it will run all of them together because they're all chained together. But at each point, I can just run only one of them at a time. So one last tip when you're creating your RAG pipelines, make sure you have some kind of dashboard to actually monitor your vector database. So in this case, for VD8, there's a dashboard you can simply download. So it's ready-made. And you can see here, for example, it shows me all the collections I have and the number of vectors I have. So I can check this in real time to see whether my vectors were ingested correctly and how many vectors I actually have and all this kind of stuff. So this is very handy, and I would recommend search for these dashboards, or if needed, implement them yourself. So yeah, this flow, I've actually created this for a competition, and I didn't take part in the competition because, when you're considering entering an online like challenge or hackathon, and then you realize actually there's not even a prize pool. There's not even a t-shirt. And so I was like, all right, I actually have other projects to do. But this is not the case with our today's sponsor, Langflow. Not only have they created this banger open source AI flow builder, but they also have an awesome community on Discord. And they actually host challenges with insane prize pools. So for example, here you can see 40K prize pool, count me in. All right, jokes aside, this video is actually not sponsored by Langflow. But seriously, their team is phenomenal, and Langflow is probably one of the best, if not the best, AI builder out there. So yeah, definitely check them out, langflow.org. But that's it now finally for today's video. If you did, leave a like and let me know in the comments what you want to see next. I hope you enjoyed it, and have a great day, and bye-bye.